The story of measuring time began when we started noticing sun in the sky. And at nights, we kept track of time by looking at the stars. Later, we developed measuring time in terms of numbers called hours. Through the centuries, Greeks settled on 24 hours as a standard day. Why 24? Because they were using base 12 numbers. Later, two sets of 12 hours were considered as a day. To measure time, people used a device called sundials. A needle called gnomon is fixed and it casts a shadow on the sundial. Depending on the position of shadow, the time can be measured. And at nights, we just relied on the position of stars. After some years, people started noticing that hours are not same throughout the years. Because of the orbit of Earth, the day hours are longer at summer and shorter at winter. So they wanted to divide a day into equal 24 parts with a device like hourglass. But the hourglass is more like a countdown device, not a time telling device. But till then, sundials were superior. Later, while studying the motion of pendulum, Galileo noticed the time taken for every oscillation depends only on the length of the pendulum, not on any other factor like mass. So that brought a new design for clocks, the pendulum clock. Most of the pendulum clock designs uses an escape mechanism and a weight hanging to it as an energy source. The pendulum clocks were so good that they increased the accuracy of time telling from 15 minutes per day to 15 seconds per day. People were happy until they started traveling in the ships. That means pendulum clocks are not useful in the seas. So that created a need for other types of non-pendulum devices. And that's how designs like wristwatches were born. The wristwatches uses a spring called mainspring, which gives a constant torque no matter how tight the spring is winded. These springs can be hand-winded to power it through the day. Some watch designs came up with a clever mechanism to wind the spring with the help of hand movements. The spring is connected to a rotor which has a mass which moves with the hand movements, and that in return winds the spring. The watches increased the accuracy from 15 seconds per day to 5 seconds per day. That solves the pendulum problem. Mechanical watches were superior until we discovered the magical properties of this rock. This is quartz. It's a special type of crystal called piezoelectric crystal. If you hit it hard enough, it will produce electricity. And that's how some lighters produce spark. And if you apply a voltage, it will deform. A tuning fork of quartz about the size of a rice grain, when jolted with electricity, it vibrates at the rate of 32,768 oscillations per second, which is exactly 2 power 15 Hz. Because it is connected to a chain of flip-flop circuit, which counts the oscillations in binary. And when the circuit counts exactly 2 power 15 oscillations, the second hand moves. And that's how the modern clocks are working. These clocks have an accuracy of 20 seconds per month, which is incredible amount of accuracy for a common man. But for science nerds, that's way too off. So after years of research, they came up with the most advanced clock till date, the atomic clock. Noticed how I said the clock loses 15 seconds a day or 20 seconds a month? That's because the oscillations of the oscillating body slows down because of friction between the parts and gears in case of the pendulum, and drag from the air molecules and other losses in case of quartz clocks. An atomic clock solves these problems by taking the electrical signal from oscillating quartz and creating a feedback loop by converting these signals into microwaves, which has the same frequency, the resonant frequency of cesium atom. The microwave excites the cesium atom from a lower energy state and passes through a photon detector. If the detector detects frequency from lower energy state, that means the tuning fork is about to slow down. So, a jolt of electricity is passed to the crystal, which is just enough to keep it oscillating. This way, even the slightest decay of oscillation is prevented, and that's why this clock loses 1 second in 138 million years. And that's the story of how humans developed a device which can precisely show how much they can sleep before their alarm goes off. And that's it. Thanks for watching.